All right, today, absolute value equations and inequalities. Now, absolute values would have been something you did back in Algebra 1, so hopefully a little recall here for you. Today, there is a lot going on. There's a lot of different things we're going to talk about. We're going to talk about absolute value equations and inequalities. We're also going to do compound inequalities, okay? Really, today is nothing more than if I were to take two problems that we did the other day and put them together into one. That's really everything is today. It's really just two problems in one. If you think about it as that, it's not that bad. Okay, so you're solving two equations in one problem. Okay, you're solving two inequalities instead of solving one. It's all the same, really. Okay, and you think about that. But last section of the chapter, look to review tomorrow, review Monday, test on Tuesday. All right, vocabulary here. A disjunction. A disjunction is a compound statement that uses the word or. The key here is compound statement. Compound statement. When you think of like in English terms, we've all heard of a compound sentence before, right? What's a compound sentence mean in English terms, John? Two sentences. A compound inequality literally means two inequalities. That's all it is. Okay? So where a disjunction is used for the word or, a conjunction is used for the word and again, all of these fall underneath what would be compound inequalities. Okay? All of that would be what is called compound inequalities. And then absolute value. Absolute value is a number's distance from zero. Now, we all know absolute value is always what? Positive. Very good. So if you notice here, the absolute value of 3 is 3. Absolute value of negative 3 is 3. Remember that. Absolute value is always positive. There will be a couple trick questions we will pull up here later. And if you can remember absolute value is positive, they're not going to trick you. You're going to get them. Okay? So as you look through here, we're first going to start off talking about solving compound inequalities. You know, here's what it's going to say. It's going to say, solve these two inequalities. Now, it's a compound inequality because it has the words or. It is nothing more than you are literally solving just two inequalities. Like this right here, that is your answer. Now, I might ask you to graph that, and you can graph that, which it does. Okay? And that's okay. But compound inequalities, nothing more than two problems to do in one. If you think about it that way, it's really pretty straightforward and simple. Same thing with the and statements, okay? X is less than 2, or sorry, x minus 2 is less than 1, and negative 3x is less than or equal to 12. Solve each one. Remember to flip the inequality there because we divide by a negative, and you're done. Think about it as two inequalities in one, and that's all the work you have to do. All right? So sometimes they'll put problems like this. So number one, this is a compound inequality because I have two inequalities. Here's an inequality, and here's an inequality. Okay, it's two inequalities compacted into one. That's why we got compound inequalities. So I want to solve this compound inequality. And anytime I solve an inequality, anytime I solve an equation, it's all the same. I want to isolate my variable. So in order to isolate the variable, I typically always need to do the opposite. Who thinks they know what they're going to do here? What do we have to do on all sides? If I were to show you something just like that. Yeah, I'm going to have to add 1. Okay, I'm doing the opposite. I add 1. The only difference here is I have to add 1 to all the sides of that inequality. Well, I add 1, cancels out. Negative 4 plus 1 is negative 3, is less than x, which is less than or equal to 0. And that is my answer. It's two inequalities all in one. That's all it is. Number 2, same idea. Negative 6, less than or equal to 3x, which is less than 15. What am I going to do to that, Garrett? Divide by 3. And I get negative 2 is less than or equal to x, which is less than 5. And I'm done. Okay? That's all compound inequalities is. You're solving two instead of one of them. Try the next two on your own. Okay, take a couple seconds here to try these two. All right, let's look at these here. What do you say about number 3? What do you say, Andy? What'd you get?
Negative 1 is less than x, or less, or
Nice job, sir. All right, number 4. Moment of truth here. Tough one. What do you say, Colin?
Number 4?
Yep.
Negative 2 is greater than n is greater than negative 4.
Nice job. Does everybody see why we had to flip those inequalities? We divided by this negative 3, which means we have to flip those inequalities. All that still remains. All those rules about inequalities, those negatives, still remain. Nothing changes there. Okay, it's all really the same properties. Same idea here. Now these are solving compound inequalities with OR statements. Now OR statements, it's very evident as it is truly 2 inequalities. Hey, there's one of them, there's the other. Solve them both. With OR statements, you literally see both inequalities as in, oh, it really is 2 problems in one. You just solve each of them. So I'm going to subtract 3. 4x is less than negative 8. Divide by 4. Now I get x is less than negative 2. Or, I throw that OR statement down there. Subtract 7. Negative 2x is less than negative 6. Divide by negative 2. What do I have to do when I divide by that negative, Sophie? Nice job. Is greater than 3. So I get x is less than negative 2. Or x is greater than 3. Try solving number 6.
5 and my sister says 7.
I feel like I was always search 5.
I know, my sister says
What'd you get for number 6? Mark, what'd you have for number 6?
X is greater than 2.
How about x is less than 2?
Oh,
Because we divide right.
yeah.
Or, what's the other one, Mark?
X is less than or equal to, greater than or equal to?
Because the other one didn't have a negative. This one had the negative. This one did not. So we flipped the first one, not the second one.
I wrote down the second one correctly. I just assumed all.
No.
I probably did it wrong.
Nope, you're good on the second one. Alright, so compound inequality is not bad. Moving on to solving absolute value equations. Now, recall, okay, absolute values. If I had something like this, absolute value of x equals 3. Okay, let's think about this here. What could x equal? 3, or x could also equal what though? Yeah, x equal 3 or negative 3. Because those absolute values would make it positive, it doesn't matter. So here's the trick to absolute value. We need to set up 2 equations. The first one's always the same. X minus 7 equals 5. The first one's always the same, no problem there. It's that second one we got set up differently. I set up my inequality equal to the opposite, negative 5. So the first one's always the same here. You see that? That second one he set up equal to negative 5. Well, why do we set it up equal to negative 5? Because those absolute value bars, if I get negative 5 on the inside, it would still come out as a positive 5. Those absolute values would make it positive. So I set what those absolute value bar equal to both the positive and the negative. And then from here, I just solve it like I would any 2 equations. I would add 7, giving me x equals 12. Add 7, giving me x equals 2. And I have both answers. So x equals 2 and 12. I get both solutions there. Okay? And again, the reason why, if I were to plug those in, think about that, plug that in. 12 minus 7, I get 5. Absolute value of 5 is still 5. 2 minus 7 is negative 5. Absolute value of negative 5 is still 5. Okay, that's why it works. Those absolute value bars means I can get 2 different answers there. Same thing on number 8 here. I'm going to set up 2 equations. First one is x plus 9 equals 13. My second one is going to be what, Andy? X plus 9 equals negative 13. Thank you. Solve both those equations. What do you get for number 8? What did you get for x to equal, Garrett?
X equals 4 and negative 22.
Nice job. X equals 4 and negative 22. Subtract the 9. And that's where you get both those answers. Good work. Now the second one, the 9th one here, number 9. Absolute value of 2x minus 4 equals 12. The key to these problems is you don't set up your two equations until the absolute value is alone. You need to get the absolute value alone first, then you set up those two equations. Because it's only the absolute value that can equal the positive or the negative. Alright? So I add the 4 here first, giving me the absolute value of 2x equals 12. Now I set up my two equations. Okay, the absolute value is alone. Now I set up the two equations. 2x equals 12. 2x equals a negative 12. Okay, divide by 2 on both of them. And I'm going to get an answer of what, Justin? What's 12 divided by 2? Negative 12 divided by 2. Good work. Yes, ma'am.
So do you not do anything with 4?
You add the 4. Oh, wait. Oh, phew.
Yeah, that's why.
There you go. I'm with you now. That was 16. Thank you. Is that why you're confused, Justin?
Yeah.
We'll go with that.
8.
8 and negative 8. I got you. Thank you. Nice catch. Just testing you.
Well,
You,
did that.
you were right on top of that one.
Makes sense.
You were right on top of that one. Good work. Yeah. Add the 4 over there. 12 plus 4 is 16. Now you set up the two equations. You get it. Good work. All right. Take a couple seconds. Try these 3. Look at them first. There is a trick question in one of these 3. Look at it and see if you can find why. All right. Let's go through these here. Number 10, I think we did pretty well on. So you get 3x plus 2 equals 7. 3x plus 2 equals negative 7. When I work them all out, I get x equals what, Andy? For number 10?
Yeah, 5/3.
5/3, negative 3. Nice job. Now, number 11. Again, some of you identify it. Absolute value of 2w minus 1 equals negative 15. Can an absolute value ever equal a negative? No, it won't ever equal a negative. I can throw anything I want to in there and it would never come out as a negative number. So my answer here is what, Sage?
No solution.
This one is a no solution. Okay? And I will tell you right now, you will see a problem like that again probably on a test or quiz, just to test you on, do you identify those absolute values? Okay? Now, if you recognize it, might be the easiest question on your whole test. But again, just testing you, making sure you kind of recognize those different things. The absolute value can never be negative. So it can't equal negative 15 no matter what you do. Okay? Number 12, what's the first thing you have to do on number 12? John, what's the first thing you have to do on number 12 before you set up your two equations? Subtract the 5, yeah. Now we get 3x minus 1 equals 28. And 3x minus 1 equals negative 28. Now I get my two equations. Again, the key is get those absolute value loans first, then do the work. 12, what was the answers to 12? Reagan, do you have them?
13 and negative 9. Is that wrong?
I don't think it's 13, is it? Did you subtract the 5 first? Or did you put your two equations first?
Yeah.
So you get 3x minus 1 equals 28, right?
Oh, wait, never mind.
Okay. Because I think you should get 29 over 3, right?
I wrote 39 instead of 29.
Ah, 29 over 3. And then you get negative 9. Is that what you said for the second one?
Yeah.
Yep. 29 over 3 and negative 9. Those are the answers. Very good. You put 39 instead of 29. Actually, that's where you get 13. All right, last thing we're going to do today. We're going to talk about absolute value inequalities. Now, this kind of makes it look confusing. I'm going to try and help you out and say you don't have to go this far as to do it. Okay? Same thing is true here. When I set up two inequalities, when I'm doing absolute value, I still want to set up two inequalities, just like equations. Anytime I'm solving absolute value, I want to set up two of them, because it could be the positive or the negative. The key is this right here, and I'll show you with the or statement because it makes more sense. Okay? My first one's still always the same. Nothing new. That second one, what do you notice about my inequality sign? Why is it flipped, do you suppose?
Negative.
Because I set it equal to, or inequality to that negative. That is the only difference with inequalities. Otherwise, you solve them all the same way. Okay, and that difference being, when I set up my second inequality, I flip that inequality. The only difference there is. Okay, otherwise everything else is the same. And, they may kind of make it confusing with the and statements here. I am just fine with you saying on a problem like this, x minus 2 is less than or equal to 3. And the second one, x minus 2 is greater than or equal to negative 3. If you want to set them both up like that, that is just fine. You don't have to do it as a compound like they did down there. Sometimes students get confused when they see this as opposed to something like this. So either way, it does not matter. But if you just want to set them both up like we do equations, that's okay. Just waiting on my drawing here, sorry. There we go. So number 13. Okay, my absolute value is alone. Good. Always want to make sure the absolute value is alone first. I'm going to set up two inequalities. The first one stays the same. 4x minus 8 is greater than 12. The second one now, 4x minus 8 is less than negative 12. Does everybody see? I flipped the inequality on that second one because I set it equal to that negative 12. And then from there I solve it just like I would. I add 8. 4x is greater than 20. Divide by 4. I get x is greater than 5. On the second one, I add 8. Give me 4x is less than negative 4. Divide by 4. And I get x is less than negative 1. Again, just very similar to equations. The only difference now is inequalities. And on that second inequality, I have to remember to flip it. Okay? Now let's do number 14 together because it's kind of unique. Okay? I want to get the absolute value alone first. Does everybody agree? Yes. So what do I want to do very first, Bailey? I would need to minus 36. Okay? Now, everybody realizes we're dealing with inequalities, right? Unique answer here. Watch. Absolute value of 3x is greater than negative 24. Now, some of you might be thinking an answer right now. What's somebody thinking probably? Absolute value of 3x is greater than negative 24. We think no solution, right? Because it's negative. That's not the answer here.
Yeah, but no one was saying it.
I agree. Because what is the answer here?
I don't know.
Would absolute value... Okay, we know it's never going to equal a negative, right? But it says the absolute value is greater than negative 24. So absolute value would always come out positive, right? So everything I plug in there, would it always come out greater than negative 24? It would. My answer here is all solutions. Okay? And it's because that inequality right there. If that inequality were flipped and it said less than, then I would get no solution because it could never be less than a negative. It could never equal a negative. But because it says it's greater than, it will always be greater than a negative. Even if I put something in there that gets me a 0, even if I put x equals 0 in there, it will still always be greater than negative 24. Okay? Take a couple seconds here. Try number 15. Number 15 is more common there. All right. What did you get for an answer, John?
X is greater than, or X is less than X is greater than.
Nice job. Here's your assignment. Oh, wait.
The third one?
There we go. Yep, I'll give you the third one.
Where'd it go?
Ah. There it is. Yeah, take that third assignment right there. Submit it on Shobi, please. Get it on to Shobi there anytime.